We will close out chapter 6 today as we end this course with inverse trigonometry. And what that means is we are going to be doing trig problems backwards. Now, what I mean by that is you are used to, when you do trigonometry, you're used to having an angle and you can try to find a missing side, that kind of thing. We are going to be going backwards. We're going to have certain information about the angle, but we don't know the angle. And you can do trig backwards and therefore find the missing angle. Now, to do that, we need to talk about the inverse trig functions. We have already talked about the trig functions, the sine, the cosine, and the tangent, okay? So now we need to discover their inverses. Before we even get into that, let's talk a little bit about inverses once again. For instance, if you know that f of x is equal to 2x minus 3, and you want to find the inverse function, okay? We want to find the inverse. I gave you some steps to do that. Set this, instead of equal to f of x, set it equal to y, and try to solve for x. So let's add 3, and divide by 2. Now I have it solved for x. So let's write it as an inverse by switching the variables. There it is. X plus 3 over 2 should be the inverse. Let's double check it. Pick an x value. How about 5? 10 minus 3 is 7. Put 7 in here. 7 plus 3 is 10 divided by 2. You're back to 5 again. It works. You've done the reverse. You've gone from y values back to the x value. This is the inverse function of this. Now, what we're trying to do here is find an inverse for sine, okay? If you recall some other things about inverses, if you can find the inverse of a function, you know it passes a horizontal line test. The vertical line test simply tells you whether it is a function or not. If it passes the horizontal line test, then you know you can find an inverse for it, and it's called 1:1. But here's the graph of y equals sine x. It kind of oscillates, and it keeps going forever in both directions, okay? This is certainly not a 1-to-1 function. We, as it stands right now, we cannot find the inverse of y equals sine x, all right? So what mathematicians have said, we want to cover all the y values from -1 to 1. How can we restrict the domain so that we'll only go from -1 to 1 as a range, and we will have a 1-to-1 function where it'll pass the horizontal line test? So what mathematicians have decided is to go from -90, which is -pi/2, to +90, which is +pi/2. You see this portion of the graph right in here? If this is the domain, these y values are the range, okay? So if we restrict the domain from -90, that should be a negative sign right there, negative, I'll put it in there, sorry. From -90 to 90, okay? This is the domain of sine of x, and then -1 to 1 is the range. It does pass the horizontal line test. We can find an inverse. The inverse would be written sine inverse of x. This is not a negative exponent, remember. Sine inverse of x. The domain would be from -1 to 1, and the range is from -pi/2 to pi/2. Now, we have an inverse sine function. That's the way your calculator is programmed, okay? And your calculator will adhere to those rules. So, we can now find sine inverses. We know that the sine of alpha in this particular problem is 8/17. You see, we know some information about the angle, the opposite side over the hypotenuse, but we don't know the angle, okay? So you can do that very readily on your calculator, okay? You want to find the decimal for 8 divided by 17. 8 divided by 17 is a big, long, ugly decimal, 0.4706. So we want to find the sine inverse of 0.4706. Okay, that's what the sine is. We want to find the angle the sine is. We want to find the angle that has that as a sine. Okay, so all you have to do is type it in. So we want the inverse function or second function sine. Okay, you're going to hit second function or shift, okay, on your calculator, and then you'll punch in the decimal point 4706, and I get it's about 28 degrees. Okay, so you can do sine problems backwards when you know what the decimal is, but you don't know the angle. Notice we got 28 degrees, and 28 degrees is between negative 90 and 90. Okay, your calculator will always adhere to that rule. All right, now you might say, wait a second, I thought sine was positive in the second quadrant. It is, but the domain, when we did sine, had to be restricted. The domain had to be restricted so we could do an inverse, so it's from negative 90 to 90, okay? And we are not considering angles in the second quadrant. We're only going negative 90 to 90. All right, so that is inverse sine. What about cosine and tangent? They all work in a similar fashion. Let's talk about each one. Here is the cosine function. Cosine function looks a lot like sine, but it has been shifted, okay? It's been shifted. I guess we would say it's been shifted to the left one, okay? One move over to the left. All right, now, so you notice that this one also fails the horizontal line test. So you can't do an inverse cosine until we restrict the domain. Well, in sine, we went from negative 90 to 90. But that doesn't work in cosine. If we go negative 90 to 90, here, it still fails the horizontal line test, okay? So why don't we go from 0 to 180? And there's the range of y values right there, if we go from 0 to 180. So we're going to restrict the domain to 0 to 180, and thus we'll have a range just like sine of negative 1 to 1. So the inverse would be cosine inverse of x with a domain, we're going backwards, negative 1 to 1, and the range is 0 to 180. For instance, in this particular triangle, we know that the cosine of an angle is the adjacent side over the hypotenuse. So we know it's 18 over 20. Okay, so let's get that decimal. 18 over 20 is 9/10. It should be 0.9. So you want to do the cosine inverse. So you want to hit second function cosine or shift cosine. On my calculator, it's second function cosine. I'm going to put 0.9 in there, and I get an angle of 25.84 degrees. Okay? It gave me the angle, and notice that 25.84 is between 0 and 180. Okay? That's cosine. Tangent is really strange. Check out tangent. Oh my word. Tangent is not 1 to 1. Tangent is totally undefined at all multiples of 90. You see here's 90, pi over 2 is 90. Okay. Over here is 3 pi over 2, which is 270. Okay. So multiples of 90. Well, I shouldn't necessarily say multiples of 90 because 180 degrees pi is a multiple of 90. So at 90, it's undefined. At 270, it's undefined. At negative 90, at negative 270, and so on. It's going to be undefined. Okay. As to the reasons of why it's undefined, I'm not sure we want to go there. If you're curious about that, ask me, and I'd be happy to explain that to you. All right. So in this, to eliminate the fact that it fails the horizontal line test, now we can go back to just like we did with sine. We went from negative pi over 2 to pi over 2. We can do that with tangent. Ignore the rest of these, and you will get the entire range of y values if you go from negative 90 to 90. So sine and tangent both have domains of negative 90 to 90. Cosine is from 0 to 180. Okay? Tangent inverse has a domain. We're going to switch. The domain for inverse would be all the real numbers, okay, and a range of negative 90 to 90. All right, so here is a tangent problem. Suppose you want to find the angle at the bottom right, over there. We know the tangent is 2 root 2 over root 73. You could do that as a decimal. You could take 2 times root 2, okay, get that answer, and divide by the square root of 73, and I get a decimal, I get 0.3310. Now, to find that angle, I would want to take tangent inverse of 0.3310. So second function tangent or shift tangent, depending upon how your calculator works, 0.3310. And I get an answer right around 18.3 degrees. This angle is very, very close to 18.3 degrees. Now, there's another way you can do this. You can do it all in one step. I first divided it out to get the decimal. You don't have to do that. You can type tangent inverse in your calculator, shift tangent or second function tangent. Then you can just type in 2 root 2 divided by square root of 73 using parentheses. Why don't I do that? Second function tangent of 2 times the square root of 2, and then divided by the square root of 73. And I get something different. Aha! What did I mess up? Tangent is 2 root 2 divided by, I must have forgotten to do the square root of, oh yes, I see what it is. I misplaced a parentheses, heaven's sakes, but it does work. You can do it either way. You can find a decimal first and then do it like I did, or you can punch that in, making sure to use parentheses correctly. I did not. And punch that into the parentheses, and you'll get exactly the same angle. Okay. So let's talk about some problems. Okay, find all the angles between 0 and 180 where the sine of the angle is 0.5. Now, your calculator is going to be your best friend on these problems. We want to find the angle that has a sine of 0.5. So we do a second function sine. We do a second function sine of 0.5, and I get 30 degrees. Okay? So I get 30 degrees. So I know this first problem that x is 30 degrees, but let's follow the directions. It gave us 30 degrees because the restricted domain for sine is from -90 to 90, and 30 is in between -90 and 90. But here the directions say we want to get all the angles between 0 and 180. And isn't sine positive in the second quadrant? Yes. So if you bring an angle over into the second quadrant so that that's 30 degrees right there, isn't this 150? Are you with me? And sine is positive over here. So take the sine of 150, and don't we get 0.5? Yeah? So the answer has got to be both of them. According to those directions, your calculator cannot give you both of them because it's restricted to the domain of sine is from -90 to 90. But I'm going around it by giving you specific directions to do otherwise. So be very, very careful on that. All right. How about the tangent of x is 0.3? Okay, do a second function tangent of 0.3. I get right around 16.7 degrees. Do I have to worry about a quadrant 2 here? No, tangent is negative in the second quadrant. So you know you don't even have to worry about it. Okay? Tangent is positive in the third. If I would have asked you, give me all angles between 0 and 360, or between 0 and 270, then you would have had to determine what the angle is in the third quadrant. But that's not the directions. Let's go over here. Sine of x is negative 0.866. Okay? Let's do that. Second function sine, negative 0.866. And I get negative 60 degrees. Excuse excuse me, negative 60 degrees because the domain has been restricted from negative 90 to positive 90, okay? So negative 60 degrees is the correct answer. If you would have had directions from 0 to 360, you would have had to do a negative 60 or 300 degrees. I don't care which way you want to say that. Negative 60 or 300 is in quadrant 4, but sine is also negative in quadrant 3, and you would have to figure out in quadrant 3, if this angle is 60, is that not 90, 180 plus 60? Isn't that 240? Okay? So if I change the directions on you and say from 0 to 360, there's two of them where it is going to be a negative 0.866. It would either be negative 60 over here or 240 degrees to get you into third quadrant because sine is negative in both of those. I hope I am not confusing you. All right, so how about cosine of x is negative 0.5? All right, so let's do cosine of x. So we'll do second function cosine of negative 0.5, and I get 120 degrees, which is in the second quadrant. Do I have to worry about anything in the first quadrant? No, because I want cosine to be negative, and the cosine is positive in the first quadrant. So I had to go to the second quadrant. And once again, it's because we restricted the domain of cosine to 0 to 180. Where else is cosine negative? In the third quadrant, but that's not between 0 and 180. Cosine of x is 0.7071. Do second function cosine, 0.7071. And I get 45 degrees. Do I have to worry about a second quadrant? Nope. Cosine is negative in the second. This one's positive. Tangent of x is negative 2. So do a second function tangent on negative 2. And I get a negative 63 degrees, which is correct because tangent was restricted from negative 90 to 90. Do I need to worry about here a second answer to tangent? Well, between 0 to 180, and 0 to 180, tangent is negative in the second quadrant. So the first answer we got was negative 63.43. So here, negative 63.43 degrees has a tangent of negative 2. But, whoa, that's not between 0 and 180, so we do not need to worry about that one, okay? But we do have to worry about where tangent is negative here. So if I come over here, because the directions say 0 to 180, I want this angle to be 63.43. What is this angle then? This is only the reference angle. What is that? So it should be 116 degrees, 0.57, if you subtract that off of 180. So now, we don't worry about this one because the directions say between 0 and 180. So tangent is positive here, so we don't want it. We want it over here. Let's check that. What is the tangent of 116.57? And I get negative 2, okay? So that's right. Now, I think I messed up on a problem. Let's double check this. When sine x was negative 0.866, we did an inverse sine of negative 0.866. Yeah, and we got negative 60. But negative 60 is not between 0 and 180, and I don't care if you change to 300, it's still the same angle. It's not between 0 and 180, so that answer is no good. We have to go to the second quadrant, like we talked about. Second quadrant, where this angle right here is 60, this is 120, okay? 120 should be your answer. It's between 0 and 180. And just check it to make on yourself certain. Sine of 120 is a positive. All right. So, I'm having a real senior moment today. My apologies. The sign, if the sign is going to be negative, all students take calculus, okay? Sign is only negative here and here, right? So can we find an angle between 0 and 180 that has a negative sign? No, darn it, you can't do it. So there is no answer at all to that problem. I think I did the rest of them all correctly. This one was negative in the second. Yeah, we did that one right, that one right. Okay, my apologies. All right, let's come down here. It says find the exact measure. Make sure you're very careful when you're doing exact measures. Most of the time your calculator is going to get you in trouble if you get decimals. All right, so sine inverse of an angle is 3/5. I like to draw pictures on this. If I'm hunting some angle that has a sine of 3/5, here we are. If the sine is 3/5, the 3 is here and the 5 is there. Yeah? You can do Pythagoras. X squared, a squared plus b squared equals c squared. 25 minus 9 is 16. This is 4. Okay? So if I'm hunting some angle whose sine is 3/5, that's the angle right there I want. What's the cosine of that angle? Is it not 4/5? Okay? How about this one down here? I know that the sine of some angle is 4/5 this time. Okay? So we'll do it again. If the sine is 4/5, Pythagoras, 25 minus 16 is 9. This is 3. Okay? So if the sine is 4/5, I'm talking about this angle right here. What's the tangent of that angle? Is it not 4/3? Okay? Third one over there. Drawing pictures to get the exact answer. All right? I want the cosine inverse to be 7/25. Okay, here we go. I want the cosine to be 7/25. Okay, let's try to find the missing side. 25 squared is 625 minus 49 equals, and take the square root of that answer, and I get this is 24. So if I'm hunting an angle that has a cosine of 7/25, that angle is right there. Now, what is the cosecant of that angle? Cosecant is the reciprocal of sine. So if sine is 24/25, the cosecant would be 25/24. And those are exact answers. If you try your calculator, like I'm going to do it on the calculator right now, okay? If I take the cosine inverse of 7/25, okay? So I want the second function cosine of 7 divided by 25. And I get some angle, okay? Now I want to take the cosecant of that. Okay, so what I can do is take the sine of that, and then I can flip it. And if I flip it, I get, don't think my calculator flips things, does it? Yes, it does, right there. And I get some real ugly decimal, okay? I get a horribly ugly decimal, and it's rounded off. It's not an exact answer. It will be 25/24, okay? But it's rounded off, and I said I wanted the exact answer. So be very careful on that. Draw pictures, and you should be able to do it and get the exact answer. All right, here we go. The last one. I want some angle where the sine is 2/3. If the sine of the angle is 2/3, then wouldn't it have to be like that? Okay, 2/3 is the sine of theta. Let's use Pythagoras. 9 minus 4 is 5, so this side is √5. What is the cotangent of this angle? Well, tangent is 2/√5, so cotangent would be √5/2. Okay? All right, if you know the lighthouse is 250 feet tall and the boat is 0.2 miles from the lighthouse, can you find the angle of depression? Now, we talked about angles of elevation and angle of depression. The guy in the lighthouse is looking horizontally. He says, oh, down there's a boat. This is the angle of depression. Always starts with a horizontal, okay? If the guy in the boat is looking straight ahead and then looks up at the top of the lighthouse, that would be the angle of elevation, okay? Always starts with a horizontal, all right? And as we talked about, I think our last time together, remember back to geometry in high school, this angle and this angle are alternate interior angles. So this angle is the same as that angle down there, okay? So what we can do to set up this particular problem is, okay, the height of the lighthouse is 250 feet. The boat is 0.2 miles. We can't have feet and miles in the same problem. So I'm going to have to take 0.2 times 5,280 feet in a mile. This is 1056 feet. I'm trying to find the angle of depression, which is up here, but we know it's the same as down there. So I want to find this angle theta. Is that not a tangent problem? So the tangent of theta is 250 over 1056. When I go backwards, I want to do a second function tangent of 250. You can do it all in one step, divided by 1056. Get your parentheses right. And I find that the angle of depression is 13.32 degrees. Okay? All right, your homework. I've got an extra problem here dealing with what we did at the beginning of chapter 6, finding the radius of that circle, set up proportions little to big. Your second problem is finding the zeros. Remember, get to all possible zeros and use synthetic division. And then there's a few problems in the book. And this will pretty much wrap up this course.